Hello everyone, welcome back to my channel after a really long time. A few things have changed in my life since then, so I had to deal with other topics. Nevertheless, I was still thinking about to improve my approach of an RC transmitter, and obviously I'm not improving it currently on the mechanical side. This is still some kind of prototype. I've started to make out a new one because the last one was a alphanumeric display, and that was kind of difficult to handle. So this one is running Texas Instruments Launchpad TM4C-1294 and hooked up with an LCD booster pack. Yes, so much for that. Before I'm jumping in, I've already given this video a test record attempt yesterday evening, and I already know it's going to take a really long time, so I'm trying to provide you with some kind of timestamps down below. It's the first time I'm trying that. I hope it will work out. I have made myself some kind of list about the topics I want to talk about. The three main parts are the design goals I had in mind when I was doing this, or the reason why I'm doing this. The second thing is the menu structure, how to configure your model you want to use, which will end with an example on the plane for using Flaperons. I will clarify this term. I think most of you probably know what a Flaperon is. And from there I'm going to slide into some demos I have prepared. For the demos, as I mentioned, I'm going to use the plane. I have set up something with the steering wheel and the pedals, multifunctions. I have something, a student-teacher system, and yeah, I'm also working on something that I can run an app on, at least on Android devices. It's not functional yet, currently it's still an approach. Okay, so I'm just going to jump into the design goals I had in mind. One thing which was always bugging me in this area was the huge amount of transmitters you can get for different purposes, depending on if you're driving a small 2-channel vehicle, or maybe you fly a plane, you have a multifunction boat. Each time you're supplied with a new transmitter, and you can pay hundreds, or if you want to, thousands of euros, dollars, whatever. And in the end, you're always buying the same thing, just configured, pre-configured in different ways. So one thing was I wanted to have the ability to change the haptic front end. That means I wanted to have the ability that I can, for example, I have some switches here that I can remove this bar of switches and attach something else like this steering wheel. So changeable haptic front end was one design goal. Then there's something which might sound a little bit abstract right now. I'm going to clarify it on the Flaperon example. I want to have a modular approach for doing the parameterization. That means usually for example, when it comes to flying planes, you have a specific amount of mixes you can use, and this idea doesn't exist here. I can make up any kind of mixer I want to. It has one side. The pro side is, or let's start with the downside. The downside is I have to be aware of what I'm doing to fulfill a specific mixer functionality. The upside is I'm completely free to do whatever I want and how often I want it to. The next thing is, next design goal is a multifunction. When for example, I have a boat with a bunch of lights on it. That's typically the example, or maybe a truck or something. And for the demo, I'm going to use this really nice looking demo panel. And also, as I mentioned, one design goal was multi-platform. So multi-platform means in this transmitter they're running a microcontroller, and I wanted to have the ability to move the business logic which makes up the functions you want to see on your model, and that I wanted to have the ability to run these on smart devices. So that will mean I'm trying to stay on the usage level from this system. From time to time I will dive just a little bit into some technical details. But I'm trying to keep myself from drowning in it. Okay, so design goals were changeable haptic front end, modular approach for the parameterization, multifunction abilities, and a multi-platform ability. Okay, so much for the entry part. I'm going to put this away. I don't need it anymore. It was just display purpose. As I said, I'm going to start off with the Flaperons example. Oh no, with the structure. I'm going to switch to some very simple visualization. As I have it running here on my laptop on my right side, that I'm going to show you a picture of that, and I have to see this picture by myself to find the right words. What you will see later in the menu is there are two types of elements in the menu. Here I've called them modules, you can call them elements, whatever. I'm starting, I think the most intuitive part is there are structural elements or modules and some which perform functions. Structural modules can be used, for example, to create mixers, that you create a structure which will end up in providing you some kind of a mixer. We will see that. So that's what structural modules are for, and then there are function modules. I'm starting to explain a little bit on the structural side, and I'm going to start to explain, that's the most intuitive part, what a channel is. A channel is pretty simple, as most of you will assume when you think of common receivers which have a few outputs where you can attach the speed controllers, servos, or maybe some light functions, something like that. So this is what a channel means. The channel manager is the very top level of the menu where you can enter into the single channels. The slot multi-switch modules, so I call it a slot, some people call it multi-switches. The idea behind them is if you add one, then more slot to one channel, it performs a multiplexing on that channel, and on every cycle you can access a different actuator, which can be an LED, which I'm going to show you, or it can be a servo, whatever. So, but if you only use one slot, it doesn't have any impact. The next thing, or the next two things, are a junction and a composition. They are kind of similar. A junction is something like, it helps you to organize things which are working on the same channel, but you want to separate them to have a cleaner organization. It's more an organization element. And the composition is, this is where the magic starts, which is going to be shown on the next picture. It's not even a slide, let's say it's a picture. The name comes from, you can stuff in different kinds of elements, and that's where the magic starts. I'm coming to that. Now on the right side, I'm talking about the function modules, and currently I have 3 different types of function modules. There can be a source. A source is everything where data are generated or provided. That can be the sticks or the switches or something which comes from external. Yes. A calculation is there are modules which, for example, when you have a signal from the stick and you apply some kind of gain to define the motion range of the servo or the speed limitation of the speed controller. So that's, for example, a gain module would be a calculation. And there are also some modules which have to deal with time. They're working over time. Later on, I will show something. There's something which is an integrator, so it integrates incoming signals. So that works over time. Then there is something like a ramp or a blinker. That are modules which are working over time. In this video, I'm probably just staying with the integration module, which will be used on the demo from the steering wheel. Okay, I'm coming to the next picture. So this looks very deep. This looks very deep, kind of epic. So once again, I will start at the channel level. As indicated, you can see I've tried to imply there are multiple channels, which are the channels which are ending up on each output on the receiver. Above that, we have the channel manager, we have the slot/multifunction, we have this junction. And now, here you can see what the magic of the composition is going to be. The magic of the composition is that a composition can contain other compositions, and it can contain the functional modules, like the calculation one, the sources, and you can mix them on one level. So the idea behind that is you can also reuse already defined compositions. So in the background, the user doesn't see that. Every time a composition is created, it's going to be a reference to it is going to be stored in a pool. And from that pool, you can grab these compositions and use them somewhere else again. We will see that on the upcoming Flaperon example. Okay, before I'm diving into the Flaperon, I want to clarify what these Flaperons are. It's something which is used on mostly smaller planes. It's an artificial name, it's artificial wording for describing putting together the function of ailerons and flaps. On this small plane, for example, there are ailerons, and each aileron has its own servo. One thing to notice to understand what's coming up is the servos are, the way they are mounted in the wings, they are mirror to each other. That means if I'm just looking for the basic aileron function, the servos are applied with the same signal, and since they're from the layout mirror to each other, they're technically moving in the same direction, but since to the hardware connections, the ailerons are moving in opposite directions compared to each other. That means one is always going down and the other one is always going up, making it able to lean the plane. For the flaps, it works different. Technically, the servos have to move in opposite directions to move the ailerons. For example, when you want to put out the flaps, move them both down, so you need some kind of mixer. So that's what a flaperon is. A flaperon is an artificial name for combining the functions of ailerons and flaps on a single set of servos. That's the idea behind it. So, I'm going to show what this means, how this is reflected in the way you can set this up in the structure. Okay, I've tried to point this out by using some colors. As you have here just shown two channels. One is aileron left, aileron, and one is the right aileron. Sorry, I just need a sip. Okay, so you have one channel for aileron left and one channel for aileron right. Once again, the slot and the junction in this case, they don't do anything. They're just there because the structure is defined like that there has to be at least one of them. And the composition left aileron, composition right aileron, this is where the magic begins. You can see inside of these compositions, left and right aileron, there's another composition called aileron common. And in this common composition, there are a few modules, a few functional modules, which provide you with the basic, with functions, with some functions which are used on both, on both sides, on the right and the left aileron accordingly, which are the same. So the idea is that both the left and right aileron reuse in the core the same common aileron composition. So this is one of them is that the stick is going to be selected, which stick is to be used to control the ailerons. Then there is a gain applied and common trim. So that means if you feel like the plane is tending to lean to one side, you are applying some kind of trim to become it neutral. And on each upper composition, left and right, you have specific functional modules. One is the trim. Usually when you mount the servos, they're never 100% neutral and you have to trim them. So I personally do it that way individually. That means there's one trim for left, one trim for right. And then there is a module which, a functional module, which is going to implement the flaps function. So, and as I said, for the flaps, the servos have to be applied with a signal which is inverted for each side, also inverted compared to each other, to move the aileron parts of the wing, move them in the same direction. So much for the theory, the boring theory. Now comes a little part where I'm going to explain a little bit what's going on from the software part, from a software part standpoint in the system. The structure you're seeing here is actually, it's a graph. So it's a graph structure, it goes down. That means every element you're seeing here goes back to the same template class, and from there I derived some base classes, and they're ending up in concrete classes. That means for the program, each of this element is actually the same. So that makes it possible for when you're going up and down in this menu. This is in the background. It's called an iterator. It's iterating through the elements, and from the iterator point of view, each element is the same. I've implemented one little trick. Since each element can, at least theoretically, contain several followers, and when you're entering into one of these followers, childs, whatever you want to call it, and you want to escape from them, you have to, or not you as the user, but the program has to know where it came from. There are two ways to explain this. I'm going to start with the more intuitively one. You can think of this structure like it's like if a person enters a maze. In order not to lose orientation, on every corner you take a curve, you leave some kind of a note which indicates you when you're coming back where you came from. And that's principle how the program does it as well. The program, to becoming technically, when the iterator enters the next level, also the next deeper level, it leaves a reference on where it came from. So every time I'm pressing the escape button, it calls this little node, and so the iterator knows where it came from. So it doesn't get lost in the menu structure. Yeah, I think that's it for that's it for the boring theoretical stuff. Let me think that I don't have forgotten anything. No, this looks good already. So what I've showed you is, on a theoretical level, how the modular design goal is realized in the modules, how the multifunction is realized. Okay, so there are two things left. How the changeable haptic front end. This is better described. I can show you that in the demo more precisely. The other thing is the multi-platform. What you can't see here, and you don't even see it in the live demos. It's just a little bit piece of information. There's something which is called the business logic, which performs the function you're seeing here, and then there is a block. There are blocks which are doing the user interfaces on the screen, and they are separated from each other. That means if I want to use the business logic on a different device, I can use the exact same source code and apply them with a different user interface. I've done that via a visitor pattern. Whoever is interested can Google that, but for the user level, it doesn't matter. It just matters for me since I'm kind of interested. Okay, now I really finally leave the theoretical part. Okay, I'm going to set up this Flaperon example on this plane. I will not set up the complete plane, that takes too long. I will just do the Flaperon example, nothing more. I'm going to set up the the ailerons on the left stick. Is it the left stick? On this left stick, yes. Take a deep breath, get going. First of all, I'm going to attach a camera to my to the box. Okay, let's go for the aileron example. I'm going to power up the transmitter, power up the camera, and I have a remote control, so I hope it's not shaking that much. Here we go. I hope so. Yes, no, maybe. Test one. Okay, this works perfectly fine. Okay, we're going to start off. I've powered up the receiver, mounted the camera. Now I'm going to supply the plane with some power. As you can see, I've unmounted the prop. It's always possible when you're playing around in a configuration that the device gets bonkers, and I don't like props going bonkers on my desk. So, give it some power to the system. Checking polarity, make sure. Okay, here we go. Oh, I think I have to. Now I'm going to. I'm going to start fresh. I'm going to. The radio transmitter has a feature which is it automatically loads the last used module. But of course, I want to start on an empty configuration, so I'm going to do this now. So it should be empty right now. Let me check real quick. Okay, here is nothing. Okay, okay, we're on channel 5. I'm going to add a useless slot. I'm adding a useless junction, and what you can do is I'm going to rename the junction to, this is junction aileron. I think it's right, on the right side. Now I'm going to set up a new composition. So this is going to be composition aileron right. I'm always leaving the first letter so later I know it's a composition or a junction. Now I'm going to add a module. No, I'm not going to add a module. I'm going to add another composition. And this composition is going to be aileron common. So this is the content of this composition is going to be the common composition of both aileron sides I've been talking about. And here I'm going to add a module. The first one is going to be the ADC. ADC is for analog digital converter, and that here when I enter in this functional module I can define, we already have a function in here as you can see. Oh, I'm on the left actually. I have to rename something. So this is already the, okay, this is, you can see the number is changing here. Also I can also change the inputs, the stick selection, but I'm going to leave it, it was already the right one. Okay, I'm adding, now I'm going to add the scale switch. On the scale switch you can set up multiple, so you can add multiple positions and you can apply each position with a different scaling. And on the column input, you could select the inputs from these switches. So you could select between different scalings with the switch. As you can see on the top, it's written limiter. For some of the UIs, I'm using some a UI base class, which have the same layout, and just the headline is going to be changed. It looks like there is a bug, obviously. I don't know. So I'm going down to 70% on 70%. Okay, like that. And now I'm adding another thing. It's a custom switch, and here once again I could add multiple positions, and once again I'm not doing that. If on the in the 0 is the default one, which is always active if there's no other. So I'm leaving it on 0 for now. Okay, we are on the. I'm going to rename this since this is the left side. Enter. and escape, and I'm going to rename the junction as, well, aileron left. Okay, now we have the function, is it working correctly? No, as you can see, when I'm pushing the stick to the right, what I want the plane is I want the plane to lean to the right, but the left aileron is going up, which means it would lean to the left. So what I do is I'm going back into the scale. I'm going to the scaling, and when I drive the scaling all the way to negative, if I leave it like that, the maximum like positive and the minimum like negative, it's always moving in the same direction. So so I'm putting both on minus 70. They're both on minus 70. Yes, now it's correct. Now it's moving in the correct direction. We have done the left aileron. Now I'm going for the right aileron. I'm going to, what's that? Going to add another slot and the junction, and I'm calling this the junction aileron right. I'm entering that, and now you can see here are 3 buttons, and first I have to set the composition for the right aileron, the specific one. This one, maybe I have to turn this on, I'm afraid. So the aileron. Aileron, right. Okay. And now I'm going through this combo pool, and from here I'm taking the composition aileron common. So I select this one. I think I'm in the wrong channel maybe. I think I'm on the wrong channel. Slot, junction. Now I'm going to use the here we go. Now what we have now is, I was on the wrong channel. So now we have the ailerons. Now I'm coming for, I think I will leave out the trim. I'm just coming straight to the flaps. The flaps, usually you want to control the flaps by a switch. Okay, it looks like I have to rearrange the camera. I'm coming for I'm going for the switch now, the flaps. So here I'm going to add a module, the custom switch, once again, and now I'm giving it 3 inputs. I'm going for the switch right here, and I've made me some numbers on the switch which are 8 and 7, and in neutral it would be 0. So so I'm going to consider that when it's pushed to the down, so 8 is activated at 0, in the middle it's 1, and on the top end it's 1. So that means 0 will be 8, 1 is neutral and 2 will be set. So when I put this switch, you can see the number down here is changing. So now I'm going to apply some output values here. On the 0 it will, on position 0 I will leave it for 0. On 1 I'm going to set it to, let's say, so I'm working on the right one. I have to go for, let's say, positive 30, and on 2 I'm going for positive 60, for example. So now when I'm using this switch, let me show you real quick. You can see that the aileron behaves like a flap. Now I'm going to do the same thing for the left one. So that means I'm escaping out from here all the way up through the channel manager. I'm going to channel 5, small, to the specific composition, and here I'm going to add another custom switch, adding these 3 inputs. And now you remember where I have been setting up with positive for the right aileron. Now I have to use negative. That means I'm going to negative 60, and this stayed neutral, and this is going to be negative 30. So now I forgot to set the inputs. This stays neutral. The 2 will be 7 and 0 will be 8. So now when I use this switch, I have the Flaperon functionality. And I have the flaps already. Okay, I'm going to save this because I'm coming back to that later when I'm going to give the demonstration of the teacher-student system. So, unfortunately, one of the batteries from my cameras went empty, and I've lost some footage. What I did in the meantime was that I have put up this small 2-channel RC vehicle, and usually this is controlled via the throttle and the steering stick, and I have already added the function to control the throttle by stepping on the throttle pedal, and now I'm going to do the same thing for the steering wheel, which is the same procedure. So actually you didn't miss anything. It's the same procedure, so you can consider this as a shortcut. Okay, so we already have seen that the throttle pedal is, the gas pedal, the throttle pedal is working. And now I'm going for the steering wheel, which is doing nothing currently. I've already put in the steering composition to its own junction. Now I'm creating a new junction for the steering wheel. So new junction. Enter. Now I'm going for the new composition. Composition wheel. And now I'm going to add the channel for the steering wheel, which is, I have to guess, 4. Yeah, it's 4. You can see it's already moving, but once again there's some kind of offset and the gain is wrong. We're going to solve this. So by adding another module, first I'm going to tackle the offset error with a custom switch. Put it to the MIDI because I have to remove the 50% offset. Now we're kind of in the middle and neutral. Now the only thing left is that the angle, the moving angle is not enough. So I'm going to escape from here, add another module. I'm going for the scale switch, add one, and I have to go over 100%. Let's say, let's go around 170%. Doesn't matter, now it's just a demonstration. Now you can see it's moving way more. Okay, this is already a nice feature. Besides the small car, I also have a little bigger one, a 1/8 scale, which can run on 6S, which is, let's say, a little tiny amount faster than this. And if you put a camera on that one, you know, the point is my 1-to-1 scale car has incredibly 100 horsepower, so as you can imagine, I'm not used to driving fast things. So it would be cool to have a way, let me pause this for a second. So it would be pretty cool to have the ability to have something like a gearing ratio, or at least a fake gearing. The steering wheel already comes with some Tiptronic buttons, which I used for the racing simulations, and I was thinking how to incorporate these things to achieve some kind of a fake gearing to slow down my too fast for me car. I'm going to show you how this is done. Turning this back on. Okay, I'm going out of the steering wheel channel and back into I'm going to the pedal. Now we're I'm going to the composition of the pedal, and here I'm going to add a few more modules. What I'm going to do on this level is I'm going to select, there's a module which is called the dynamic scale. And dynamic scale is a bit different to the scaling switch. It doesn't have a distinctive way to choose between the positive and the negative part of the signal coming in, but it has the ability to use another composition to change its scaling factor dynamically. So this is the first key to create something like a fake gearing. So I have set up this dynamic scaling, and in this user interface you don't see a lot. So what I'm going to do is I'm going to set up a new composition which will act as the trigger. I'm going to this trigger composition, and here is where the magic begins. I'm going to add a module, and now, as I said, here are these push buttons on the steering wheel, which are used for the Tiptronics, the Tiptronic simulation and the racing games. And so I can make use of them by setting up a custom switch. I'm going to the custom switch, and I give this custom switch 3 positions. The 0 will be neutral. Now I have to remember, I think position 1 is input 1 and position 2 is 2. So now when I push these buttons, you should be able to see that the position selection down here changes. This is 1 and this is 2. So this will be the push button for shifting up, this is the push button for shifting down. I'm going to apply some values to it. The down will be minus 30%, and the up position will be plus 30%. Now there's something which is a mode. On this left side there's still a bug, it's not showing it straight right away. And this, now the middle knob here has a specific function, you can change the mode. Usually it's, by default it's running in continuous mode, that means when I'm pushing this button, you can see here, it outputs the corresponding amplitude. When I set it to pulse, now you won't see anything because it's too slow for the refresh rate of the display. No, the other way around, it's too fast for the refresh rate of the display. Now it's just creating one pulse of the assigned amplitude for one cycle. Okay, this is the first key to creating the fake gearing. The next module, now I'm going to add another module, which is the integrator I've been talking about very early in the video. I'm going to use this integrator, I'm going into it, and now I leave the maximum at 100%, and I put the minimum to 0. Remember, what we're doing is the output of this composition is going into the dynamic scaling. So if it would be possible to reach a minimum less than 0, it would reverse, so the car would go. If you gear down too much, you would put your car into reverse mode, which is kind of real, since actual cars doing the same way. So, but nevertheless, I'm going to set this to minimum of 0%. 0%. I'm setting the rate. The rate is how fast the integrator sums up incoming amplitudes. And if I set the rate to 0, it has this special function, the special meaning, that it takes over the incoming signal at once. That's what I want. The default stays at 0. Here's also another bug in the UI. There's something to reset. You can select a reset, and when you press the reset, the integrator goes back to its default value. So now everything is set up, and if we now press the pedal, probably nothing will happen. That's what we see, because we're in neutral gearing. And if I hit the pedal and push the up button, it should start turning. And if I press it more and more, it's taking the next, and the next gearing. And this is also true for shifting down. So what we have now is a setup which is where you can use the pedal to drive your car, to accelerate it, you can use the steering wheel to control it, and you can even fake gearing. And if you're one happy owner of a crawler or something, or at least a vehicle which actually have a shifting, which has a gearbox, you could use that for the real gearbox. How cool is that? I only have this thing and another direct drive vehicle. Okay, this was a demo on the steering wheel, and yeah, I overtalked it a bit. The goodie was faking this gearbox. Okay, now we're coming to the next part. We had the two examples of the Flaperons and the steering wheel and the pedals. Okay, I'm going to place this to the side. There's no room over here. The example of the Flaperons and the steering wheel, the pedals and the fake transmission. The next two things, the first thing I'm going to show is something which are wizards, so they help you to shortcut repeating procedures. Now, as you can see, on the very top level of the menu there is a function, there's a menu point which is wizards. If I'm going to the wizards, there is something internal trim. I'm not going into this now, I'm going for the 2-channel model, which is this car right here. Okay, I'm going in, and here you can already set a few parameters. You can select the channel which is used for the throttle or the gas, which is 1. I know I have to set the scaling to minus 70%, so I'm going for that. Now, turning the wheel, the wheel, the wheel, the wheel. Around minus 70, it's good enough for this purpose. The steering will be channel 3. And about the scale here, I'm not 100% sure. I leave it like that. Now if I'm pressing enter again, in the background, two compositions are made up, one for throttle, one for steering. And both of them equipped with the stick selection, the scaling switch for putting up a gain, and custom switch for doing offset correction. This works in the same way, it uses the same mechanism which is used to save and restore the parameter from a saved model in the storage in the device. So this is using the same mechanism. So I'm pressing the enter button. I need to create something that you can actually get a message that something happened. Okay, now I'm going for the channel manager. I'm going for channel 1 at this slot. And now I'm going to the composition pool, and here you see these are the pre-assembled compositions. I'm going to use the gas. I'm going in there, and as you can see, there's a ADC channel selection, the scale switch, the custom switch. I'm going for the custom switch to correct the offset. Yes, now it's good. And here we go. Now I'm going for the channel 2. Composition pool, steering, and it works. So this was a shortcut to set up a 2-channel vehicle pretty fast. So this is the example for the wizards. Now I'm going for the example for the multi-switches. So this is a little PCB which is based on a STM32 blue pill, and some credits have to go to Roger Clark, I guess is his name, an Australian guy who wrote some libraries to integrate this nice little microcontroller evaluation board to the Arduino environment. And in this case, I just used the Arduino environment to reach the purpose I want this to fulfill as fast and as simple as possible. And what this thing can do for me is it reads in the PPM signal I've been talking about from the receiver, so it only gets positive and negative in one signal wire, and on the signal wire all the information from each channel is bundled. So this signal is getting disassembled by the Arduino sketch in there, and then there are 10 pins which perform output of a PWM signal. And this signal can be configured to either serve 0 to 100% in order to drive LEDs or motors, or it can be configured to apply the needs for driving modelcraft, speed controllers or servos. I'm going to use, I have hooked up 8 LEDs here, 1 sip of coffee. 4 of these LEDs I'm going to make up a configuration that I can use them on the on these 4 2-position switches, which is going to be on and off. And here I have two 2-position switches. There's a difference in the sketch I've put on there. The first 4 LEDs are tied to one channel directly. The second 4 are all fed by this slot/multi-switch function from one channel. So it's going to end up that I'm using here 4 channels for the first 4 LEDs, and I'm using the last channel to control 4 LEDs. Once it's 1 channel per each LED, and the second 4 are each controlled by 1 channel, or accessed by 1 channel. Okay, so going for that, I'm going all the way out. Now comes some repeating work. I'm going to the channel manager level. Now it comes some repeating action in here. So I'm going to set up the first LED. I hope you can see that it became pretty bright outside. So I'm going to add a slot, new composition. Now this time I'm not going to name every composition, at least not for this demo purpose. I hope you forgive me. Add module, I'm going to use the custom switch, and I'm adding 2. Select 1. Now you should see down here when I'm using this is the change between. To make it 100% lit up, I have to go to 100% or a little more. And then to make it go off completely, I have to go to -1%. I forgot something. Currently the LEDs are getting no power. They are powered from this DC-DC power supply. For the LEDs it doesn't matter, but if I put it in a boat with some bigger power consumers, it's better to have a decent supply. So I'm going to put this in now. Okay, I hope this will work. You know what? I'm going to change the position of the camera. Okay, now I'm going to do that for the rest of these other 4 LEDs, which will take a moment. I'm going to put this video on fast forward. Alles schmeckt besser aus der Heldentasse. Now you can see if I use these 4 switches, I can control each of these 4 LEDs. I'm trying to point it more to the camera because they're very tiny. Yeah, I think it's visible.
At this point I have to admit I had a few issues during the preparation of this demonstration, so I'm afraid I have to leave out the demo part of the slot multi-switch function on the bottom 4 LEDs. That means I'm going to have to do a sequel video on this. For now I'm going to jump to the student-teacher demonstration.
So okay, for the demonstration of the teacher-student system, I'm afraid I can only show, I can't show it on the plane because I'm a bit limited by my setup currently. For example, the biggest problem is I do not have a second transmitter, and the way I can show you this is by doing a loopback. So this is the receiver which is currently binded to the transmitter, and what I do now is, as you can see, the ppm output from the receiver is connected to the external pickup device from the host controller. So the thing which is happening now, I'm going to assign this stick to one of these channels coming here, and what you will see is when I unplug, also when I'm going to unplug this cable, that on a certain loopback channel you will not see any more activity. So that means when it's plugged in, this receiver gets the input from this stick and then can show me it on a visualization, and when I unplug this cable, this visualization will freeze. So I can show you this only in a sense of a loopback setup. Okay, so I'm going to the channel manager and I'm going to channel 1, the usual procedure, composition. So channel, I'm going to select this right stick here, so you can see the number here is changing. And now I'm going for one of the channels which have been on the plane, the aileron. So I'm setting up another junction. I'm going to this junction, placing another composition here, and another ADC input. So in this case, I'm going to set the ADC to 5 to 4. So the thing what is happening here, these sticks on the host controller are channel 0 to 3. So that means the channel 4 is coming externally via this cable. So this is the loopback I've been talking about. So that means when I'm pushing this, also when I'm moving this stick, we can go back to channel 1, which is this number 3. If I change the 3 to from 3 to 2, it's not reacting anymore. So this is the proof. This stick is channel 3. So, and this stick is applied to the transmitted channel 1, and then coming via this loopback cable coming via the loopback cable on, so everything above index 3 is something which comes externally, so this is the loopback. And if I, as I said, if I pull off this cable, the number freezes. So the number freezes, and if I carefully plug it back in, the number is running again. So the idea behind this is it's an elegant way to set up a student-teacher system, and the idea is that if you plug in a receiver on this external data gathering device, you already have a wireless student-teacher system. There is one thing more. As a teacher, you want to have the ability to exclude, to cut off the control from the student to the plane. And the way to do this is, after the input from this channel, I'm going to place a scale switch. And let's say I'm going to use, this is switch number 1, I'm going to use switch number 1 to enable or disable the student's access. So I'm going to the scale switch, I'm adding 2 positions. One is in position, the position 1 is this one. So you can see at the top here, it's already, at the bottom here, it's already reacting to this switch, and you can also see here some visualization bug. So now I'm going to the bottom position, and I'm put these things to 0%. Come on, 0%. Fine tuning I'm doing by knobs. So now, so this, that means if the push button is pushed to the top, it has 1% scaling, which is equal to 1, and at the bottom it has 0. That means if it's at the bottom, scaling is 0, the student has no access to the ailerons anymore. So I can prove that. I'm going to, in this case, I'm going to misuse an ADC for displaying purposes. So I leave it on channel 0. So if I move this stick, this right stick here, you can see nothing is happening because the switch is pulled down to the bottom position. And if I push it here to the top position, the student once again gets control. So he can access that. Yeah. And so you could also use completely different scaling factors. You could also use, instead of this 2-position switch, 3 or n position switches and change the scaling very dynamically. So also you could do that for every channel of the plane individually. That would be also possible. So since, as I said, I'm limited by my equipment currently, I can't create this showcase currently. I will have to find someone who can borrow me a system. So yes. So now that this is done, is there something left to do? Yes, the next topic will be a little showcase for the Android app. So now we're on my Android smartphone, and I wanted to show the experimental app I've done. This app is based on the business logic part, which is also running on the microcontroller in my radio transmitter, and on top of that I've changed the user interface. So we're tapping in there. I have Bluetooth not activated. So what you see here are a lot of colors. The background from these colors is when I'm using the Qt creator, I'm, like most people, I'm doing some kind of a mixture between using the graphical assistance to create the proportions and the layouts, and I'm always leaving me some, I call it hook widgets, where I can hook in other widgets during runtime. And to see the proportions and the layout, I'm giving these widgets some colors during the development phase. That's why everything is so spectacular colored. You can see on the right side there are these channel icons. It's possible to enter in by just tipping with a finger on them. Here's a button for creating a new slot. And here you can also enter in by tipping with a finger, create a new junction, and go in. And when you tip on this area about the paper basket, you can type in a name for a composition to be created. I call it just C1 for the ease. And when I push the push button, composition 1 is getting created, and you can drag and drop it to the operating side. And here you can also enter in by tipping with a finger with it. And on the bottom line, you can see there are these functional modules. For example, this one is the stick select, where you can change the number from which stick you want to use. Here's this custom switch, and it's pretty similar to the implementation on the microcontroller user interface. You can create some positions. Yeah, so the whole thing is currently super experimental, even more than the radio transmitter prototype. I just wanted to play around with the concepts, with the drag and drop, and stuff like that. So the missing Bluetooth in the beginning was the idea behind this is that I want to be able to create a configuration on a smart device and then transfer it via Bluetooth to the radio controller to make things a little easier, or maybe even to have a mode where the whole logic is running on the smartphone. Yeah, there are just some ideas. So this is still a very experimental state of this app. So I'm not sure if I'm going to work on this further. Maybe I use it, maybe I don't use it, I don't know. So yeah, that's so much for this app. So finally the end of this video has been reached. I thank you a lot for your patience. Probably I'm going to do a few sequel videos with a better quality and more detail, or add a few parts.
The point was I had 2 weeks vacation and I had this idea in my head to make some kind of little documentation for those who are interested, or maybe just for myself, I don't know. So yeah, thank you for your time, and maybe see you in another video.